Year 11, welcome to your weekly introduction video. It's going to be quite quick and just only one task for you in addition, one My iMaths task for you to do. The rest of the time needs to be spent preparing for the test, okay? I can't give you any more time than that because you just don't have the time, alright? So you're going to have to do some stuff on your own. Okay, but what we're looking at this week is, if I can just get the objective back up, to learn non-calculator style trigonometry questions. So what you sort of experienced last week is that you could use a calculator for all these questions. But there could be some types of questions on trigonometry on paper 2 as well, where you're not allowed the calculator. Just to get you warmed up, can you have a go at question 1 where you can use a calculator? And then question 2 and 3 is revision of surds. See if you can remember how to do those. So you shouldn't be using a calculator for question 2 and 3. Okay, so stop the video and have a go. Okay, so if you've had a go at question 1, hopefully that was easy enough. What I would do is actually, for this question, I would label this distance as x, okay? And we can find x, because x, if we do it relative to this 25-degree angle, then x is the opposite side, and 30 is the adjacent side. So now we know the sides. We question which trigonometric function is it? Is it sine, cos, or tan? Well, because it's opposite and adjacent, we're going to be using tan. So we write down the formula. Tan of my angle is equal to the opposite, which is x, over the adjacent, which is... Hang on, let's not be lazy. Tan of my angle is equal to opposite over adjacent. Lazy approach there. Now put in the numbers. Tan of my angle, 25 degrees, is equal to the opposite over the adjacent, x over 30. So x is equal to 30 tan 25. Okay? Now at this stage, there's absolutely no reason for you to actually work out what 30 tan 25 is in your calculator just yet. Okay? What you're going to do is you're now going to work out what x plus y is. So what's this? Okay? So I would say, let's call that z. So the entire length, we'll call that z. So again, we're going to say that tan theta equals opposite over adjacent. Well, the opposite this time is z, and the angle is all of this, so it'd be 37. Okay, so it'd be z over same adjacent, 30. So z is equal to tan 37, sorry, it's not written right, 30 times tan 37, okay? Now, you can easily see that y is just z minus x, so y is equal to z, which is 30 tan 37, minus x, which is 30 tan 25, and just use a calculator, making sure that your calculator is in the right degree setting. So 30 times tan 37 minus 30 times tan of 25, and according to my calculator that is equal to 8.62 centimeters to 3 significant figures. Okay, and just looking at that seems like that's probably a very reasonable answer. Okay, so that needs to be easy for you by now. Okay, it's very basic stuff. That's sort of C grade, B grade kind of work. Okay, so hopefully that's easy. Now, what about simplifying surds? Okay, Again, you can't use a calculator. This is a paper 2 question, but to simplify the surd. So if you remember how to simplify the surd, what you need to do is split up the 112 into 2 factors, where one of those factors is a square number. Now, if you're stuck, one little cheat you can do is you can express 112 as a product of prime numbers. So, what's 112? Well, certainly 2 can go into that, can't it? So, what's 112 divided by 2? 2 into 11 is 5 with 1 remainder. That's 56. Okay, so 56 and 2. What about 56? Well, that's 28 and 2. 2 is a prime number, so circle. Okay, then we've got 7 and 4. 7's a prime number. And we've got 2 and 2. So what I'm able to do now is actually use that to understand what all the factors are. Now I reckon 2 times 2 times 2 times 2 is 16. So 112 can be written as 7 times 16. I know that's a square number because I'll get that times that, something times itself is a square number. Okay, so I can use my product of prime factors to find the overall factors and see if I can find a square one. So I can rewrite this as root 16 times root 7. One of the factors that you split into must be a square number. And what you want to do is find the biggest square number. Okay, otherwise you won't be simplifying fully. And now we can see that that is equal to 4 root 7. Okay, 4 root 7. Okay, I hope that makes sense. You should be able to do that. You will have learnt that last year with Mr. Angus. Okay, let's get rid of these. Right, what about rationalising the denominator? First one's easy. At the moment, the denominator is irrational. We can change that by multiplying top and bottom by the square root of 2. The square root of 2 divided by the square root of 2 is 1, so you're not changing the value of 2 over root 2. But if we now do that, we're going to get 2 root 2 over 2, because root 2 times root 2 is just 2. And now we know from fraction work that we can just cancel off the 2's, and we're left with root 2. So 2 divided by root 2 is the same as root 2. Okay? That's rationalising the denominator. You're turning the denominator of your fraction into something that is rational. Okay, so it's basically how we divide with surds. Now, the other one, you just have to remember what to do first in this situation. And what you do first is you multiply by the denominator, but instead you change the sign. Top and bottom. Okay, you change the sign. And then use a bracket. So that's 10 lots of 4 plus root 3. Divided by 4 minus root 3 times 4 plus root 3. Okay, numerator you're going to end up with 40 plus 10 root 3. In fact, you know what? I'm not even going to bother expanding the numerator because it may be helpful not to. So don't expand the numerator. Denominator we will expand though, because look what happens. You do 4 times 4 is 16. And then you do 4 times root 3 is positive 4 root 3. And minus root 3 times 4 root 3 is minus 4 root 3. So together they cancel out to nothing. Okay? Minus 3. Okay, because minus root 3 times positive root 3 is negative 3. So my final answer is 10 times 4 plus root 3 divided by 13. Now the reason why I didn't expand the numerator is that maybe this fraction would have cancelled. It doesn't, but it could have done. Okay, and perhaps I wouldn't have seen it if I would have had expanded the numerator. Okay, so numerator you don't need to expand, denominator you do, because that gets rid of the irrational numbers from that denominator, which is the whole point of rationalizing the denominator. Okay? So I hope that all makes sense. If you don't know how to deal with surds, you don't know how to simplify a surd, you don't know how to rationalize the denominator, you need to learn. Okay? That's a very, very important skill that will be on the exam. Okay, now, so reason why we've learnt all that is because sometimes these trigonometric questions you won't have a calculator for. Now, if that is the case, the question will almost always be about a specific angle. It will either be 30 degrees, 45 degrees, or 60 degrees. Okay? And what I am expecting you to remember, for example, is that the sine of 30 is equal to a half. That would be one example. The sine of 45 degrees is equal to 1 over root 2. The sine of 60 degrees is equal to root 3 over 2. And then I expect you to remember them for the cos and tan as well. Okay? So you have a choice. You can either just write this table down and just commit everything to your memory, or you can take this approach, okay? You can remember these two special triangles. We call these the special triangles. Now, you're looking at this and think, well, one's a triangle, one's a square. Let me explain to you the special triangles. The special triangles come from an equilateral triangle and a square. They come from an equilateral triangle of side lengths 2. Okay? And then what I do is I split the equilateral triangle down the middle so that I get a right angle triangle. What that means is that the distance halfway is 1. So now all I'm doing is just working on the left-hand side triangle. Okay, so the base of it is 1, half of that 2. So what is the height of this triangle? Well, I can use Pythagoras to work that out. Let's just call it x for the time being. We know that x squared plus 1 squared is equal to 2 squared. So x squared equals 2 squared minus 1 squared. X squared equals 3. So x equals root 3. So the height of this triangle is root 3. And we also know the angles because it's an equilateral triangle. I know that this angle must be 60 degrees. I already know that I've got a right angle, 90 degrees. And this angle must be 30 degrees because it's half of the angle within the equilateral triangle. Okay? So that shows me that, for example, if I pick sine of 60, well, that's opposite root 3 over hypotenuse 2. Okay? What about if I go for tan 30? Tan 30 is, this is my angle, 30. Okay, opposite is 1. Adjacent is root 3. Okay, so tan 30 is equal to 1 over root 3. We could also say that tan 30 is equal to 1 over root 3. We rationalise the denominator. Okay, it's root 3 over 3. Okay, it's the same thing. Okay? So if you just remember that special triangle, you can find out all of the signs of those particular angles. Okay? Let's just quickly look at the other special triangle, because that helps you only with the angles 30 and 60. But the square, what we do again, we chop that in half. If I chop that in half, what I know is this angle is 45 degrees and this angle is 45 degrees. And what I do is I make this a square of side length 1. Okay? Not side length 2 like the equilateral triangle. And so what is the hypotenuse side? What's the length of the diagonal? Well, call it x again. X squared equals 1 squared plus 1 squared. x squared equals 2, x equals root 2. So this length here is root 2. So now let's say I want to find cosine of 45 degrees. Or pick a 45 degree angle, and you've got the adjacent, which is 1, over the hypotenuse, which is root 2. Again, you might rewrite this as 1 over root 2 and rationalise the denominator. And so cosine of 45 degrees is equal to root 2 over 2. Okay, so both of them are the correct answer. Okay, so you can either remember these trigonometric ratios for 30, 45 and 60. You can just commit it to your memory, or you can commit the triangles, the special triangles. So the actual special triangles are this triangle here and this triangle here. You can commit those to your memory, and then you're able to work out all of the ratios. Okay? But you need to know them. You know, perhaps the last thing you do before you go into a paper 2 exam is you have these written on a piece of paper. Obviously, you can't take that piece of paper into the exam with you. You'd have to then throw it away. And then you go into the exam, and the first thing you do is write down the ratios that you need to remember in case that question comes up. Okay? For paper 4 and paper 6, you don't need to, because you'll have a calculator for that. So the calculator will be able to help you. Okay? Right, so here are some exam questions. Stop the video and have a go at them. Very easy, actually, now. Okay, root 12, I hope that's painfully easy by now. That would be saying root 4 times root 3, split up so that one of the factors is a square number. So that's going to be 2 root 3. So my answer is 2 root 3, okay? Solve the equation cos x equals root 3 over 2. So what I know is cos x equals root 3 over 2. What I need to do is shift cosine root 3 over 2. But you don't have a calculator, so you just need to know it, okay? So let's have a look. Cosine root 3 over 2, then the angle is 30 degrees. You need to know that. Okay, so x is equal to 30 degrees. And just, that's just telling me that's what size my angle needs to be. Well, that's between 0 and 90, so that's the right answer. So x is equal to 30 degrees. No calculator required. Okay? Same here. Theta is an acute angle. Tan theta equals root 3. Find theta. Well, theta is equal to shift tan of root 3. Again, we just need to know it. Maybe you've written these down in the test. You can just look at your table now. Tan of root 3, 60 degrees. Okay? So you're seeing it's always these nice numbers. It's always going to be 30, 45 or 60. Okay, here's another type of exam question. Write the list of numbers in order starting with the smallest. Okay? Stop your video and have a go if you haven't already. Okay, so all you've got to do is work out what they are. So sine 60, I can tell you, it's root 3 over 2. Okay. Cosine 60 is a half. Tan 60 is root 3. And then we've got root 2. Don't need to change that. So all we need to do is decide which one is the biggest. Now again, well, what we obviously know is root 3 is bigger than root 2. Okay? But is root 3 over 2 bigger than root 2? Well, no. I mean, you need to find a way of kind of working that out. But root 3 over 2 is definitely smaller than root 2. And obviously, half is going to be the smallest number here. So we're going to start with a half. Then root 3 over 2 is going to be smaller than root 2. And then root 3 is going to be the biggest number. Okay? So I hope all that makes sense. So you need to be able to do basic angle trigonometry without a calculator. You need to recognise the ratios of sine, cos and tan of 30, 45 and 60. Let me know if you've got any problems.